Okay, so here is the next problem. Just from the book, I'm going to copy it. Okay, let me get my pen here. So just to make things, just to convince you that the axes don't have to be a certain way, so we're going to tilt them a little bit. So here is the x-axis, and here is the y-axis. They are still at 90 degrees to each other. That's not, doesn't look like too much like a 90, but so here is my y-axis, positive y-axis. Okay, and here is the horizontal. This is 15 degrees, and we will deal with this when we do forces and inclined planes and so on. So here I have three different forces, and here they are. You have force F1 is in this direction, F1 is in this direction, F1, and it has magnitude, this is F1, and it has magnitude 50 newtons, it's a force. So just put 50. And this angle here is 45 degrees. And I have another force, F2, and it's 20, magnitude 20, but it points just straight in the y direction. This is F2. And it is equal to 20. And then there is F3, and it's straight down. Usually it's the weight of the object. It's straight down. Straight down meaning it's at 90 degrees here. And it is F3. And the magnitude of F3, the magnitude, for all of these, it's, by the way, it's magnitude, yeah. It's not the magnitude for F3 is 57 units. And the question is, what's the net force, meaning F1 plus F2 plus F3? Okay, so let me go here, get my calculator. So first of all, F1 is in this direction, and I want to break F1 into an X and a Y component. So the X component of F1 is this. That's the X component of F1. So I'm going to call it F1. It's the adjacent. So it will be the magnitude of F1 times the cosine of 45 degrees because it's the adjacent. Okay? So I'm talking about this little triangle here. It's at 90 degrees here. So the X component of F1 will be F1 times the cosine of, in this case, it's 45 degrees. And it's in the first quadrant, right? Because this is X, this is Y. So it will be 50 times the cosine of 45 degrees. I put equal sign here, I will do it in a moment. And the Y component of F1 will be F1 times the sine of 45 degrees, and that's 50 times the sine of 45 degrees, right? Because that's the Y component. So this is the X, this is the Y, or if you like, you can look at it from this side here. It's the height of this. Opposite over hypotenuse gives you the sine, so the opposite must be the hypotenuse times the sine. So that's that. Then F2 is along the Y direction, meaning it makes 90 degrees with the X. You can just say F2, the X component, it doesn't have any. It's just strictly in the Y direction. But just mathematically, you can write F2, X component will be F2 times the cosine of the angle it makes with the X-axis. Well, F2 is this way, and the angle it makes with the X-axis is 90 degrees. And that's simply 0. Cosine of 90 is 0. And then F2 Y component will be F2 times the sine of the angle it makes with the X-axis, which is also 90 degrees, and so it will be 20 times the sine of 90 degrees, but 20 times the sine of 90 degrees is just 20. Sine of 90 is 1. Now we will deal with F3. I think I drew it a little bit kind of bad, so let me get it. It's just straight down. Let me draw it this way. Let me redraw it. So here is F3. Just straight down. This is F3, and it has a magnitude of 57 units, or 57 newtons. What angle does it make with the x-axis? Well, it makes this angle with the x-axis. Well, let's extend our axes to figure out what it is. So here is the x-axis extended this way. Here is the y-axis extended this way. So I know this is 90. So what would this angle be? Well, the sum of the angles of a triangle are 180. This is 90 already, so these two must add up to 90. So 15 plus something gives me 90, so this angle must be 75. But then this angle here is 90, right? Because this is the y-axis, this is the x-axis, so that's 90. So if this is 75, what should this one be? It should be 15. So this is 15, this is 15. If this is 20, this will be 20. So what angle does it make with the x-axis? With the x-axis? If you like, you can go from here all the way here. So it's 90 plus 90 plus 90 plus 15. So it's 270 plus 15. So it's 285. Yeah, I think it's 285, this angle here. Going all the way to here. It's 285, yeah. 90 plus 90 plus 90 plus 15. So it's 285. So you can say it's simply, let me write it. Yeah, let me write it and then I will comment on it in a moment. So I would say F3 x component will be F3 times the sine of the angle it makes with the x-axis. The sine of the angle it makes with the x-axis, again, is 270 degrees plus 15 degrees. And that turns out to be the same as the sine of 15 degrees. So if you add 270 using trig, or just plug in 285, it would be like this. F3 times the sine of 285, which will be mathematically, you can plug it in. The sine of, you can, as you're watching this, make sure you write in your calculator, sine of 285. I get negative, the sine of, I'm sorry, the x goes with cosine, not sine. What am I doing? X is cosine. Yeah, cosine. So it's the cosine of 285. Cosine of 285 is 0.2588. And the cosine of 15 is also 270. Yeah, the cosine of 15 is 0.9659. The cosine of 285. Something is incorrect here. 270 plus 15 is 285. I am missing something. Yeah, I actually made a mistake. I just plugged it in. The cosine of 270 plus theta is the same as the sine of 270, as the sine of theta. So it would be the same as F3 times the sine of 15 degrees, just by using trigonometry. And so you can double check. The sine of 15 is the same as the sine, as the cosine of 285. Anyways, just plug it in. So you get what? What is this one? Is 57 times. Let me just write it in terms of the cosine. Cosine of 285, and that gives me what? Times 57. I get 14.75. 14.75. And let me just double check to make sure it's correct. 57 14.75. Good. I don't want to make a mistake at the very end. And then the y component of F3, the y component, F3 y component, would be F3 times the sine of the angle it makes with the positive x-axis, which is this one. It's 270 plus 15, which is 285. And the sine of 270 plus 15 is the same as the negative cosine of 15. So it would be negative F3 times the cosine of 15 degrees. Which makes perfect sense, actually. Because if this is 15, what's adjacent to it? The adjacent to it is actually the y. The y would be the adjacent. But it's negative, so it would be the magnitude of this times the cosine of 15, but it's in the negative direction. Whereas the x is the opposite to it. This is the x. And so it would be the sine. So good. Okay, so so either way, so do 57 times the sine of 285, or negative 57 times the cosine of 15. Either way, you will get 57 times. You will get negative 55.06. Negative 55.06. Okay, that's that. So now, what's the net force? The net force, they want us to find the total force. It consists of three forces, so I need to just add the three vectors. It would be F1 plus F2 plus F3. So the x component of the net force will be the x component of force 1 plus the x component of force 2 plus the x component of force 3. And what are they? Let's add them. Oh, what's the x component of force 1 and y component of force 1? Let's do them quickly. So 50 times the cosine of 45. You get 35.36. And this one is also 35.36, because cosine of 45 and sine of 45 are the same. So let's add them. So it will be 35.36 plus, what's the x component of F2? It's 0. Plus the x component of F3, that's 14.75. Okay, so let's add those, plus 14.75. You get 50.011. 50.11. And then the y component of the net force, F net, y component would be F1 y plus F2 y plus F3 y, and that's equal to what? The y component of F1 is 35.36 plus the y component of F2 is 20 plus the y component of F3 is negative 55.06. Negative 55.06. And what do we get? We get 35.36 plus 20 minus 55.06. That gives about 0.3. 0.3. I think it's supposed to cancel. I mean, if we keep everything exact, basically. So that's that. So now, what is the magnitude of this net force? F net. Well, first of all, F net as a vector would be, it is 50.11 in the x direction and 0.3 in the y direction. 0.3 in the y direction. What's the magnitude? F net, the magnitude of this force, which we denote this way, or just F net? it would be the x component squared plus the y component squared square root. So you have to do 50.11 squared plus 0.3 squared, and then you add them and take the square root. So let me do that. Plus 50.11 to the power 2 to 8.5. It will be basically 50.11. Yeah, 50.11. 50.11. Because when you square this, it becomes even tinier. And when you square this, it's huge. 50 squared is like 2,500, whereas this one is like, what, 0.09, I think? Yeah. So it would be tiny. So anyway, so that's f net. And if you want the angle, since the x is positive, the y is positive, the angle will be tangent inverse of the x, of the y divided by the x. So if you do tangent inverse of 0.3 over 50.11, 0.3 over 50.11, it would be basically at 0.343 degrees. So basically at 0 degrees. And I think that's all the book was asking. Let me just double check. Yeah, exactly. Yeah. That's all it was asking. So I would like to do this example here from the book. It's I think in the chapter 3, number 16. I think it's just a quick problem and it does the job. So it says you have a vector here. You're given that vector A is equal to what? 4i hat minus 2j hat, and we're given that vector B is negative 3 I hat plus 5j hat, and we're given that there is vector F, and that vector F is equal to A minus 4B. A minus 4B. And so we would like to write down vector F in component form, and then they want us to maybe draw these also. Well, drawing them would be too much, I think. Let's see. We will see. All right. So first of all, vector F is A minus 4B. So it will be vector A minus 4 times vector B. Vector A is 4i hat minus 2j hat. Vector B is minus 3i hat, 3i hat plus 5j hat. Okay, 5j hat. So we have 4i hat minus 2j hat, and then plus negative 4 times negative 3 is 12 I hat, and then this is scalar multiplication of a vector. So we minus 4 times 5 will be negative 20 j hat, and so this is vector F. This is vector F. Then we add them. 4i hat plus 12i hat is 16i hat, and then negative 2j hat, negative 20j hat is minus 22j hat. That's the vector F. In other words, the x component of the vector F is 16, and the y component of vector F is minus 22. If you like to draw it. Actually, minus 22 in the y direction, so it should look this way. Here's x, and here's y. 16 and minus 22, so here's 5, 10, 15, so here's 16, and then minus 5, minus 10, minus 15, minus 20, so minus 22 is here. This is minus 22, minus 22, and this is 16. So our vector F points in this direction. That's vector f. Okay. If I say what's the magnitude of vector f, then the magnitude of vector f would be the x component of f squared plus the y component of f squared square root. And so you would have 16 squared plus negative 22 squared square root. And you would have the following: 16 to the power 2 plus 22 to the power 2, and you take the square root, and you get 27.2. 27.2, that's the magnitude. If we say what's the direction, well, you have to find this angle here. And so we will use tangent inverse. So the angle, let's call this angle here theta, will be tangent inverse. You can do the y over the x. You can just put positive 22 over positive 16, or put negative 22 over 16, but the tangent will give you some negative quantity. And since you're already in the fourth quadrant, it's fine. It will give you the right quantity. And so if you want the angle, it would be tangent. I'll put tangent inverse of the y. It would be the y component of f over the x component of f. Over 16. So it would be minus 53.97 minus 53.97. That would be the degrees. It's in degrees here. Okay. And I just want to say why the calculator gives you that. If you remember, let me erase here. The sine of an angle, if I plot here, this is theta, and this is the sine of theta. Remember, the sine looks like this. It is a function because it passes the vertical axis test, but it's definitely not a one-to-one function because the horizontal test crosses it multiple times, so it's not one-to-one. The same thing for the cosine. For the cosine function looks like this. Sometimes we put the parentheses, sometimes we don't. So this is the cosine. It's also not one-to-one. So what they do is they put the restricted domain. So they say the sine function has an inverse if we work in the restricted domain. And the restricted domain is, this would be pi over 2 or 90 degrees to negative pi over 2. From minus 90 to 90. Similarly for the tangent, there's theta, there's tangent theta. Remember, the tangent approaches positive infinity as you approach 90 degrees, and minus infinity as you approach minus 90 degrees. So it will look, this is the tangent. It has a vertical asymptote, and the same thing here, and the same thing here. So it's not one-to-one either. It's only one-to-one in this restricted domain between minus 90 degrees to positive 90 degrees, or minus pi over 2 to positive pi over 2. And so if you give the calculator a tangent that happens to be negative, when it gives you the inverse, it will give you where it is negative, which is in the fourth quadrant where you have 90. A negative angle. Negative means below the x-axis. This is minus pi over 2, and here this is pi over 2. This is, I feel like, let's work in degrees. Minus 90 degrees, and this is positive 90 degrees here. So it will give you an angle between these two. But if your angle is actually here, you have to look at the picture to figure out whether you are, if you give it a negative angle, it will by default give you here. But your angle might be here. And also if you give it a positive, if y over x turns out to be positive, then you might be here or you might be here, because y over x if y is positive and x is positive, then y over x is positive. But if y is negative and x is negative, then negative over negative is positive. So you could also be here. So you have to look at the picture. So that's the reason the calculator gives you those. All right. So that's the end of chapter 3, and please do the homework for chapter 3, and then look at the worksheet, and then we're ready to start motion in 2 dimensions. Which is the subject of the next chapter. It's really like chapter 2, but now in 2 dimensions, because we know about vectors now.